definitely just see the
All right, girls. I can't say it enough that as you're learning new integrals, you always want to go through. Can you simplify it first? Like, could it be factored, cancel, divide?
Integral and amplify.
True. Okay, I'll write that up here.
Wow, I'm so good at that.
That's just a step above this one.
No,
So anyway, yeah, I mean, I've taught high school long enough to live through that one. Anyway, I mean, especially in co-ed classes, people start giggling. I'm like, okay, so it's integral of each of that.
Oh, I didn't process. Did you just process? Yeah, I'm
I didn't hear what she said.
Okay, so anyway, amplify. Always check and see if you can simplify it first. Don't forget this. You can get your head too wrapped up, girls, in integration by parts when I teach it to you, partial fractions, inverse trig functions, blah, blah, blah. Okay, they can look very, 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 very similar. They can look very, very similar. But always try to simplify. You go down this list, substitution, and then the next thing we learned was inverse trig functions. The next thing we'll learn is integration by parts. We'll learn partial fractions. And actually, when we get to these, some of these will look like parts at first, but you can easily do it by substitution, okay? Some inverse trig functions aren't even really, you're not even able to do them with inverse trig functions. You require substitution or simplification. And you have a mix of these going on between your homework and the ones we're going to do today, okay? Please, I cannot emphasize that enough, that you go in order whenever you see a problem, and I'll model that for you today, okay? All right, so let's go first to number, in your homework.
Rose, you know every single time you're absent from physics, you're just like, wow, it's so quiet today.
All right, good, 30. All right, this is number 30, the integral.
Remember that one time that Rose laughed?
From negative square root of 3 to, this number 30 to 0 of x over 1 plus x squared dx. Girls, if it had been upside down, I would have simplified it. I would have broken it up into two fractions, okay? Or done long division. If the top's higher than the bottom, simplify or do long division. I'll do one of those for you in a little while. But the next thing is I can't simplify this, but substitution is going to work, isn't it? This is not arctan. Substitution, you should stop at first. It looks like arctan now that you've seen arctan, but you shouldn't even be looking at that yet. You want to go, can I simplify it? Is it substitution? I promise you want to do that, okay? So I'm going to let u be 1 plus x squared. Du is 2x dx. Do you see mentally I saw that piece with the x dx? So I have 1/2 du equals x dx. All right, so x dx is 1/2 du, and I have 1 over u. My new numbers, I'm going to go ahead and get them. Sometimes I will, sometimes I won't, depending on how intricate the problem is. But on substitution, I always change it over. And so when I filled in negative square root of 3 squared, I'll get 4 on the bottom. And when I fill in 0, I get 1 on the top. You might want to change your limits of integration. And so I haven't actually, I don't know if I've ever worked this problem. I haven't worked it this year. Was it one of the ones I assigned? All right, 1 over u is the only 1 over u to the first is the only one that takes you to ln u, okay? If you have 1 over u squared, you make it u to the negative 2 and do your integration. So this one's ln 4 minus ln 1. So I have negative 1/2. If logarithms are subtracted, I could divide and just call this ln 4. It's not one we can look in the back, but there's a chance that I would look through this and not see it in my multiple choice. Okay? And I guess maybe some of you looked it up on Slater and
Yeah,
got
it's
an
not
answer.
finished.
Huh?
It was not finished.
Okay, so let's keep I suspected that, given logarithms and exponents, you ought to always tie those in together. Alright, first of all, does everybody understand the logarithm rule I used there? This is 4 over 1 would come from ln 4 minus ln 1. Or another scenario that some of you may be looking at is ln 1 is 0. So either way, you've got ln 4 left, okay? Now this exponent I might bring up top, and so I have ln 4 to the negative 1/2, which gives me the square root. However, I'm going to have ln of 1 over 4 to the 1/2. Boy, this is moving all around. This is ln 1 minus ln square root of 4. Negative ln 2.
Yeah.
Was that the answer they got?
Yeah.
So I just kept on with my algebra. So I moved this up. I got 4 to the negative 1/2. I moved that down, 1 over 4 to the 1/2. I went back to that and got negative ln 2. I could have gotten it up here. Watch this. I'm a little surprised I went this route with this now that I think about it, but I'm always thinking logarithms, exponents, and I kind of went that way first. But more likely, a lot of times ln 4, ln 9, I'm prone to write them as ln 2 squared, or ln 3 squared, or 16, ln 4 squared. And then I could bring this down. It'd be a little bit quicker, easier to look at than all of that manipulation there. That'll give me negative ln 2. I like this direction a little better. And like I said, usually ln 4 I think of as an ln 2 with the power, any power that you can grab, because logarithms and exponents go together. Alright, so that was number 30. Thank you, Grace, because that was a prime example of I didn't use inverse trig functions. I'm going to always stop at substitution first. If you don't, you're going to be really upset when test time comes, because your pieces won't fit sometimes. And also you're wasting good time that you need somewhere else. One that was most asked about that you could make careless mistakes on was that one, where'd it go? A bunch of us did it, where I let u be 4x squared or something. Where would that one go? There's an x on the outside.
Oh, 5, the first one?
Yeah.
No, the first one.
5, okay. So 5.
She was talking about an x being on the outside.
Yeah.
I'm not the only one with that.
Alright, so here's number 5. Alright, 5 is the integral of 1 over x square root of 4x squared minus 1 dx, I think. Let me double check.
Yes.
Okay. Alright, I would first of all think of what if u is 4x squared minus 1. And du would be 8x dx. I would need an x on the top. And then it would be a substitution problem. Okay, but x is on the bottom. So now I'm pretty convinced it's an arcsecant with this u thing right here, right next to each other. So I'm looking for this pattern, u square root of u squared minus 1 du, or u squared minus a squared. By the way, I don't know if I gave you any yet, but that doesn't have to be a perfect square. Like, if you have 7, then a is square root of 7. That's fine. You don't have to have a perfect square. We're going to do some interesting things with perfect squares today. All right, so I'm thinking u, I'm asking myself what is being squared. Right now, I'm not going to let u be 4x squared minus 1. I'm going to just let u be 2x. And du is going to be 2 dx. So I get 1/2 du equals dx. And we are going to use a form of substitution here. I also want to make a note to self what a is. Right now it's just 1. It's the square root of the number in the back. So now let's see how my pieces are going to fit if you didn't get this. This is the square root of u squared minus a squared. And now I have this sitting here. Dx, let's go ahead and take that out and put in 1/2 du. Alright, so I have this accounted for, and I have this accounted for, and I have this accounted for. Now, what can I do with that x? I can go back up here, and if u is 2x, then half of u is x, right? So I can put in half of u right here. Do y'all see those 1/2s cancel? And then you have a completely like good arcsecant problem. So you have 1 over A, arcsecant's one of the ones with 1 over A, right now A is 1. Arcsecant or inverse secant, U, which was 2x, over A, which is 1, plus C. I hope that's answering that.
Yeah.
Okay. Takes a lot of practice. You know, like, again, I think I've mentioned many times I'm tutoring A, B, and BC students from LaGuardia. And they meet class a lot more, but also I have just like worksheets and worksheets and worksheets that their teachers just keep giving them intricate intervals, and yeah, we don't have the time for that, just seeing you like 2 times a week sometimes. But please work the ones that I've carefully selected and really, really think about them. We'll do some more today. All right, other questions on your homework? All right, this is 33. All right, 33. All right, 33 is the integral from 0 to ln 5. E to the x over e to the 2x, 1 plus e to the 2x dx. All right, let's just try it. Well, first of all, I can't simplify it because the top is not one higher than the bottom and there's not a common denominator. So there's nothing I can do there. So I try to simplify. I'm thinking of substitution. I don't think I can get away with substitution letting u be 1 plus e to the 2x, because then I would need another e to the 2x somewhere. And so now we're probably headed toward arctan if we can pull that off. Let's see what happens. So I'm going to let u be just e to the x, and du is e to the x dx. So if you're going toward an inverse trig function, you're taking what's being squared as your u, not your whole thing. All right, so now that's looking pretty good. This gives me 1 over 1 plus u squared, and all of this can come out, and this is du. It's a little unusual for that thing to be sitting on the top and not mess you up with inverse trig functions. But that just, the du just fits so nicely there. Another thing, if you have a number up here, like I'm left with a 6 or an 8, it doesn't matter what the number is, but if I'm left with a number, just factor it to the outside and then you have a 1 over, okay? And so now I have arctan. I'm going to switch my limits of integration here. When x is 0, u is 1. And this is good practice. Thanks for asking this one. What is e to the ln 5? That's just 5. Excellent. All right, so this is, arctan is also one of the 1 over a's. Arcsine's the only one that doesn't have 1 over a. Oh, right now though, what is a? 1. All right, so I have 1 over a, which is just be 1. Arctan of u, was it e to the x over a, from 1 to, oh, I'm sorry. If I change my limits of integration, I don't ever want to go back from 1 to 5. I don't know why they use that high up in there. Okay, I've changed my limits of integration. If you didn't change your limits of integration, girls, listen up. On multiple choice, nobody's going to see what you're doing. But if I'm grading it as a reader and all of a sudden you write something that they call, you got a word for it. They have words for everything that you can do. A linkage error. If you were not going to change your limits of integration, but you used a form of substitution and you still wrote 0 and ln 5 right here, we might not keep grading it, or we might count on not give you that point for your setup, because 1 and ln 5 have nothing to do with this u. So my suggestion is, if you think you're going to go back to x, just temporarily leave off your limits of integration until you make your decision, so you're not saying something that's incorrect. So just, if you're like messing around with, and you hadn't decided what you're going to do with your limits of integration yet, just start setting up your integral and leave the limits of integration off until you make a decision what you're going to do with them. Because the limits of integration need to match the variable you're talking about. Steve?
If I go back to x, what if I like change the limit of integration back to the original, but like for like when I plugged in a and u, I left it like when I changed.
Just don't write them. Don't. If you have this, if you have anything with a U in it, you should not have 0 and ln 5 right there.
Okay, but like if I have 5 and 1, and then when you like wrote arctan of e of x, for my limits of integration, I changed the back.
That's fine, as long as you're talking apples to apples. At that point, I would be talking apples to oranges, and the reader would have to, they would have already told us what kind of decision to make there. Okay? I mean, that's justified that they would look for that. You need to say what you mean and mean what you say. Alright, so anyway, I kept with this. As Sophia was saying, there's times on these problems that I just get frustrated with changing my limits of integration and what have I done. Sometimes I just leave them off and go back to x, and I told you that would happen as time goes by. In integration by parts, a lot of times I don't change my limits of integration. Here it's so easy, I mean, like, why not? Alright, now let's look at this. Arctan 5 minus arctan 1, which I'm assuming you would have gotten had you gone back to x and the other things. Arctan 1 is pi over 4, you are expected to know that. Arctan 5, I don't have any idea what it is. I know tangent goes up to infinity, so it's possible to have an arctan 5, but you can just leave it like arctan 5 minus arctan 1. So if you know 1, you can say arctan 5 minus pi over 4. If you have a calculator, you can type it in. It all depends on what type of question you have. What did they have in the back on that one? Anybody check? So they did it.
But that's like the same. They wrote arctan 5 minus pi over 4 and then did the decimal.
Okay, alright. The funny thing is you're not really gonna have decimals on one they want to see you work out, because let me tell you, if I had this on the calculator version, I wouldn't do anything but slap it into my calculator. You know what I mean? Like this one. If I look down in the multiple, if I'm on the calculator section, the second multiple choice, and I see all these decimal answers, I'm not gonna play around with it, I'm slapping it right into my calculator. Which happens sometimes with a fundamental theorem of calculus, which we're gonna talk about. Okay, so these are great questions. Again, you can watch me do them and go, yeah, I get that, but unless you're super duper playing around with them, it takes a lot of clicking in your head for it to be your information. So I strongly suggest that you practice, practice, practice. I'll give you more than you could bear. And then you can pick and choose. Any other homework questions? So we've seen some interesting things so far. Okay, let's look at number, I saw an interesting one I wanted to do. Let's look at number 17, which most of you don't have your book out. This is number 17. So you can take notes or watch. It could pop up in homework at some point. I haven't decided exactly what you have. I know it's on my syllabus, but it may not be what happens.
Still on 385.
Yeah, I think it's 387. Yeah, 387. So this was in the mix, Grace, of everything, and you can see what would be in the mix. So originally, you shouldn't even be thinking arctan yet. You should be thinking, should I simplify, should I substitute? Because once you see arctan, just like once you see 1 over u, it's hard to not think that and not make too many rash decisions. I would simplify this. I wouldn't even go, I would stop it. Stop number 1. If the top's higher than the bottom, do long division, okay? Unless you could just integrate it. Like for instance, if it had a number, I could just integrate that now. You used to couldn't, but that's gonna be 4 arctan of x plus c. Like that's just a straight up arctan, okay? All right, so here, do y'all see how the top is 1 degree higher than the bottom? Do long division. And things work out really nicely when you get that chance. One reason I chose this problem is I had to put in 0 coefficients to the numerator and the denominator. I forgot, in all honesty, if Elena looks at my sheet, she'll realize that I forgot to put it in the divisor. And I had to squeeze in that little 0 x, okay? The reason I'm confessing that is you kind of catch yourself if you forget, because things won't line up when you just subtract. Okay, I was in a hurry, getting careless, wanted to try the problem before I went to homeroom. And if you don't put it in, it won't line up, so you'll catch yourself anyway, okay? X goes, all of this goes into all of this x times wherever you want to put that. That's x squared plus 0x squared plus 1x. Subtract, 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 cancel, cancel, negative x plus 0. And now I have a remainder. Do y'all see how that is a less power than that? Y'all see that? Okay, so what is my answer? My answer is the integral of x minus x over what? X squared plus 1. So what's interesting about this problem, it's an extremely interesting problem, is it started out as a simplify. It's going to end up as a substitution and not have anything to do with inverse trig functions. It's one thing I love about this book. It's all mixed in. If they didn't do it, I'd have to give you worksheets where it's all mixed in, where you're constantly making your decision. Safety net at the top's a degree higher than the bottom, do long division, and it'll divide up into things that you can distribute your integral through. All right, so this one, alright, this one's just x squared over 2, and this one I'm going to let u be x squared plus 1, du is 2x dx, 1/2 du equals x dx. Alright, so this part was x squared over 2, and then I have minus. I'm just going to set up this other integral so I don't make a mistake. X dx is 1/2 du, and then I have 1 over u. Which takes me to a logarithm. And so I have x squared over 2 minus 1/2 ln u plus c. Don't really need the absolute value here because u was x squared plus 1, which is always positive anyway. Remember, once you get to ln x, 0, it's undefined there. It only exists in the positives, unless you put the absolute value. Then it still has a vertical asymptote at 0 like this. This is ln x. And then the absolute value of ln x looks like this, which if you didn't grab that derivative thing I was talking about, the derivative of ln x is 1 over x, which is this, okay? While this is decreasing, its derivative should be negative. And these start off really big negatives and go towards 0. This one is decreasing. And its derivative should be negative, and all the same stuff applies. Starts out small and then gets really big negatives. So once again, it addresses the fact why that absolute value would be there, okay? Because if you go backwards from 1 over x, it would have to be ln of the absolute value of x, or it wouldn't compensate for everything that you needed.
Can you still put the absolute value? Or?
Oh, it wouldn't hurt.
Okay.
Yeah, wouldn't hurt. I just want to do it if it's multiple choice and you've got to make that decision. When you take derivatives, the absolute value can disappear because then you're talking about the whole thing. One year they actually kept the absolute value in one of the multiple choices and it didn't belong there. I didn't like the problem. Anyway, I don't want to get into that now. Okay, oh yeah, I'm another one that looked interesting. Let's see. Where was it? Oh, I don't see it. Okay, I'm doing an example from the book now, and really I call this engineering. You're starting to engineer things to make them work, okay? An engineer, figures out how to make things work, whether they're biomechanical engineering, mechanical engineering, chemical engineering, whatever it is that you might see. You might have to engineer something for it to integrate. So let's look at this interesting problem. By the way, on 385 are all the integrals that you should know now. I'm updating it for you. It's all in your study guide. And then on page 386, they have an ABC scenario that takes you through what I just did. Does it simplify? They all three questions on page 386 look a lot alike, but you do them all differently depending on where everything lies. Alright, so anyway, actively watch this one. I actually love this stuff. Okay. An x squared on the bottom, you know, my mind can't help but flitter through arctan, but it sure doesn't look like an arctan because we've had cute little x squared plus 4s or possibly an x squared plus a number without a perfect square root. I cannot use substitution, why not? There's no x, and I would need a 2x, I would need like the derivative of x squared minus, yeah, good. The derivative of x squared minus 4x would be 2x minus 4. I don't have anything that I can, you know, come up with for that. I can't simplify it unless I do what? Morgan, I think it was your word. Were you the one that said it? Okay, I can't factor that one, but I can engineer it to where I can factor it. Okay? So,
Completing a square.
Oh my
God.
Did someone say engineering?
okay, so I'm gonna manufacture something that will. I was trying to refrain from saying completing the square because when I completed the square in Algebra 2 as a student, which if I was your teacher in Algebra 2, I refused to give you a list of things to do. I wanted it to be common sense. My teacher said, move the constant number 1, number 2, divide by the lead coefficient, number 3, and I followed those steps and I was so scared I would get lost in there. I memorized my way through it. Don't do that. Use common sense, okay? You know what I'm gonna say to 7. Alright, girls, and let's quit talking and just listen, okay? Usually don't have that problem in here. And this is a real important day. I'm gonna tell 7 just to get out of the way. Alright? Just like
I never actually know to do this.
watch. That you never had to know anything. Pretend like you don't know the words. 'Cause I'm in my mind not completing the square. I'm doing what you suggested. I'm gonna make it to where I can factor. The 7 is in my way, so I'm saying get out of my way. Alright? Now you're gonna put something in that you wish you had. Okay? The very best thing I could have in there is a what? A 4. Okay, don't try to memorize your way through it. Try to understand it, okay? There's a lot of things. I bet you're on the right track. I'm gonna need a 2 in a minute, okay? But if this said plus 4, wouldn't that be a perfect square? X minus 2 times x minus 2? So to me that's common sense. But girls, I can't just walk up to an equation. I can't just walk up to an equation and go, well, I wish there was a plus 4 in there, unless I balance it out. Think that was my big fluffy sleeve.
Oh no.
Please come back. Did I do that much?
Maybe you've just scrolled down.
There. Alright, so I'm like, oh, I see, girls, and this is I think what Carla was talking about. Y'all see an x minus 2, x minus 2? I would love to have that. If it's x minus 2 times x minus 2, then this back needs to be a 4, and I balance it with a negative 4. Okay? To me, it's common sense. And so I have the integral of 1 over, this is x minus 2 squared plus 3.
Why
Okay?
would you just? I just never do it like that. Like I just.
We haven't ever done one of these.
No, but like.
It's like a shortcut of completing the square.
It's like common sense. It's like the way that I taught it to you, actually, Anna. You have done this. Also, and the difference that you're going to have to do this is we don't have an equation. There is not another side.
Oh, actually,
And
I
how-
do that.
Yeah.
I just skipped the plus 3 because I'm like, oh, I just like.
There are ways that you can break up the 7 to make it work.
Okay.
There are some people that do this. 1 over x squared. 1 over x squared minus 4x plus 4 plus 3. Like, you can manufacture it that way also. You can make the 7 a 4 and a 3. And you get the same result. Go whichever route you want. That makes sense to you. Okay? And I think I'm going to have to talk about this some more, though, based on some more difficult problems. But Those of you that saw like from there to there, if you can make that happen, do that. This is gonna have to be like, we're gonna run into these over and over again where you're gonna make something that you wish you had, okay? All right, now, do y'all see an arc 10? All right, so I'm gonna let U be x minus 2, du is dx. And A is, like I told you, not a perfect square. This is u squared plus a squared. A is always the number. So I have the integral of 1 over u squared plus 3, and du is just an easy dx switch. And keep in mind, most people write that, I'm sorry, dx is what? du. And a lot of people just write it on the top without the 1. So that leads me to 1 over a arc 10 of u over a plus c. You'll have some of these to do for homework where you've got to figure out your own method through this. But there's not like a big list of memorized things that are even going to work for your problem. Use common sense and manufacture a perfect square, which is why it's called completing the square, which was news to me years after I learned it. I didn't know why I was doing that.
Same. Oh my gosh, that just.
You're making a perfect square.
Oh
I think we
so
get.
dumb. I'm literally so dumb. How did I like survive?
I think it's because we have so many words that don't make sense in math, like asymptote and logarithm.
I guess so. I don't think for things to make sense. Like it's just that's never my first guess that they make sense. Oh my goodness.
All right, so here's one. Another example in the book, if you want to look back at page 384. 3x minus x squared. You would be so stuck on this problem. And there are some that you get stuck on that you're like, oh, well, first of all, let me say, there's some you can get stuck on and never undo. It doesn't mean the integral doesn't exist. It just means you can't figure out the antiderivative, okay? But yes, there probably is an antiderivative. It's a fundamental theorem of calculus, okay? It's just that you'd have had to have noticed that this happened to you one day, unless you can get it of a certain form. All right, I'm thinking maybe, okay, first of all, I should try U substitution just flat out. And I should see if I just know it, which I don't. U substitution is not going to work for the same reason we talked about before. And so now I'm thinking, ooh, could I do that little fancy thing with completing the square, okay? It's going to be better for me to do this. I don't like that negative coefficient. So I'm going to make this negative x squared plus 3x. And girls, again, this is not something that you're going to jump to. It'd be something where you run through your list of stuff and it's a non-calculator problem, so you still got to come up with something, okay? All right, so do y'all see I scooted it over and I'm ready to make a perfect square, okay? Now, how am I going to get a 3 in the middle? What would that have had to be? X minus what? X minus, or plus? 2.25?
Yeah.
1.5 and 1.5?
Yeah.
Oh, okay, gotcha.
Yeah,
I got you, sorry. You were giving me what to add. Very good. All right, don't you need half of 3 here and half of 3 here? Like it said, x squared minus 6x. How would I get a 6 in the middle? I would have to have x minus 3 and x minus 3, which forces that to be a 9. Do you see how I'm unwrapping it instead of memorizing my way through it? To create a perfect square, you have to cut it in half so it says the same thing in both parentheses. So this is a good one to jump into. I have 3 in the middle, so I need half of 3, okay? And what would that force me to add on the end? I have to complete it with 9/4 or 2.25, okay? Now be really careful here. I'm not a...
Was the 3x being negative after you factor out the negative from the x?
Thank you. So it would be negative. Thanks, Sophia.
You were right. That was Morgan's talk.
Thanks, Morgan.
You didn't want to say
Thank you. So it needs to to be minus both of those, which will make a difference in my answer. Either way, I'm gonna add 9/4. But have I really added 9/4? This was a negative x squared, it's accounted for here. Sophia hopefully would have, and Morgan would have caught my answer when I was, my mistake right now. That would be negative x squared, what would this be? 3x, and what is this one really?
Negative
9/4. So how do I balance out this thing I introduced to it?
add 9/4.
Oh, by the way, I was thinking about a seesaw, like balance, like I started with that and I put 9/4 on this side. Okay, so I need to like balance out the seesaw and put something over here. The reason I was saying that is down by Macy's, down around, what
The
square is
station?
that?
Herald Square?
Herald Square. There's seesaws, big,
By
huge
there.
metal
I've
seesaws.
heard
Have you
of
seen them
those.
yet? It looks so funny. You guys want to send me a picture. No, this is by myself. I was running. I guess I could have met a stranger if I wasn't so shy.
Just do it by yourself.
I didn't know how to seesaw by myself. Run back.
I
and
bet you
forth.
could do it.
I could just like stand in the
So
middle.
fast.
Yeah.
Yeah, that's what I used to do actually.
I've done that before. Okay. Anyway, there's seesaws in Herald Square, right outside Herald Square, not in Herald Square. Alright, back to this. This is so important. I should be talking about seesaws. Listen. I really have subtracted a 9/4, so I needed to add a 9/4. Okay? So now this is the integral of 1 over the square root of 9/4 minus x minus 3/2 squared dx. That's how you manufactured this. You wanted it to be x minus 3/2 times x minus 3/2. Alright, a right now is what? 3/2. Alright, write that down for myself. And then I would be really careful with u. Don't get careless with u. U is x minus 3/2. I'm really just checking to make sure it's a nice fit from du to dx. I don't want to forget that I might have an extra coefficient in there that I need to take care of, because I forget that quite often. So now I have the integral of 1 over the square root of 9/4, which you might want to write as 3/2 squared for yourself. Oh, I need to rewrite all of that, I'm sorry. So this will go straight to 1 over u, which is 3/2. I'm sorry, 1 over a, so you could call that 2/3. Arc sine, this one's arc sine because the variable's in the back, of u over a over 3/2 or times 2/3 plus c. Now, this one had limits of integration, 1/2 to 9/4. So I'm going to go back to, I forgot to write down the limits of integration. I was so intent on getting this solved. 3/2 to 9/4. Okay, so when I went to u, I might would have wanted to do this. The integral of 1 over the square root of 9/4 minus u squared, and du is dx, and my new numbers, 3/2 filled in here would have given me 0, and 9/4 at the top. What's 9/4 minus, I'm filling it in right there, this is super messy. What's 9/4 minus 3/2? That's 9/4 minus 6/4 or 3/4. And so if I've done that, then I'm never going back to x. I'm going to have 1 over a, I'm sorry, my mistake. I could say I made that intentionally to see if you were watching me. Arc sine doesn't have a 1 over a in front of it. Arc sine, only arctan and arc secant, okay? Arc sine doesn't have a 1 over a in front of it. So this is arc sine of u over a from 0 to 3/4. So this one gives me arc sine of what's 1/2 minus arc sine of 0. And so inverse sine of 1/2 is pi over 6. And arc sine of 0 is 0. So I get pi over 6 for my final answer. Let me see if I got that right. Pi over 6. Okay? You are expected to know how to do your inverse trig functions. Arc sine you choose from first and fourth quadrant as you do with arctan, and arc cosine you choose from first and second. Okay, so those were interesting. Now, you'll have some of those to do for homework. Let me see about my other notes to self. Let's see. $387.21. Oh, this one's very interesting. $387.21. And so always do the ones that I pick for you, because they'll require. I'm kind of doing all the thought process right now. You've got to do it yourself. This one's very interesting, so I'll let y'all brainstorm through it. Such a great problem. Okay, so how are we going to solve that? This is 21, still on 387.
Let's see.
If the top is higher than the bottom.
With the top side.
Yes, very good. I don't know if anybody would see it if you don't just have a single denominator, okay? But Morgan can make this the integral of x over x squared plus 1 dx minus the integral of 3, 1 over x squared plus 1 dx. She can make this and this. You can separate it into fractions even if you have a bigger denominator. It's unusual, but great idea, okay? And this one is a U sub, and this one is an arctan. Y'all see what I mean? If I just stop there? We're going to do that a lot this semester where I get it. I work a lot for you and I set it up. Doesn't mean you need to stop there though, because then your test won't go well. You know that feeling of like, oh, I wish I would practice a little bit more. So make sure you finish every problem, okay? Are y'all okay with that? Oh, Caroline, we had this, x minus 3 over x squared plus 1. We couldn't do long division because the bottom's bigger. You know, we had just done some sort of completing the square stuff, but that didn't really lend itself since we're trying an x with the square. And so Morgan had the idea to split it up into 2 fractions. And that one is a sub, and this one is arctan. Okay, that's number 21 on 387. All right, let's see what else. Let's see. 402.57. Wow. Interesting. I don't know why I picked this one, but here we go. All right, page 402, number 57. My guess is this is from carried over from another syllabus from last year. And I bet it's right underneath a lot of the stuff that we've been doing. But on 57, it just looks different. And I just think in my brain that you know how to do these things, but I gotta make sure you know the lingo and what to do. So I have y is equal to e to the x times a cosine 3x plus b sine 3x and it says show that it satisfies the differential equation w prime prime minus 2y prime plus 10y equals 0.
What does that even mean?
I know, that's why I wanted to give it to you. Because so many, there are no W's on the board. I don't know which one looks like a W.
No, because you
No, you said W.
Did I? When did I say W?
When you were writing double prime.
Why double prime? Did I say W?
Yeah.
Yeah.
God, that's so scary. I was worried about y'all, now I'm worried about me. That's really scary.
Stop.
So anyway, that was probably confusing. Big news, wise or confused. Okay. Anyway, what would you do? Cry.
Wait, what? It's probably skim it and
Yeah. Girls,
Oh.
it says show that if y equals this stuff, show that y equals blah satisfies the differential equation. This is a differential equation.
So take the derivative of
I would be very literal, wouldn't you? I would just find y prime and y double prime.
Yeah.
Okay? So I'm gonna find y prime. And it's probably not gonna be very pretty. I'm gonna do the product rule, I guess. Alright, first times derivative of the second. Hey girls, you've seen my tests, so let's do this, alright? I don't hold back at all. Let me get some room. Let's get rid of this guy. There's a W. Is that why I said W? There's a W. Okay. Alright, so right there at the bottom of Ross.
Ross, more like.
Okay, so y prime. And another thing I want to say is I can't imagine that there's a student in here that's not going to have a job that requires you to be very intense and very thorough and very precise. I can't imagine that you wouldn't walk into work and not, so this should be okay, let's just be careful. Having said all of that, let's also pray I don't make a mistake. Okay? Alright, so I would sort of look for an identity first, but I don't see one, so here I go. Alright, A is a coefficient. The derivative of cosine 3x is negative sine 3x times 3. The derivative of sine 3x is cosine 3x times 3. So that's the first derivative. Oh, no, and I haven't finished my chain.
Other side of the.
Alright, and then A cosine 3x plus B sine 3x. And the derivative of e to the x is this, girls. You copy it down. You say ln of the base, the derivative of the exponent. Okay, so I don't want to ever get lazy with e to the x.
Base derivative of the x.
Alright, now before I take the second derivative, I might want to see if I can clean this up at all. But I don't know that I can. I could factor out an e to the x. And let's do that. So we're always give me good notation so I know what you're doing. This is negative 3a sine 3x plus 3b cosine 3x plus a cosine 3x plus b sine 3x. That I wish I had a's and b's so I could actually add like terms. But I think I'm prevented from doing that very effectively right this minute. So now let's take the second derivative. All right, so a big product rule. First times derivative of the second plus the second times derivative of the first. All right, so do y'all see why I write it down? Because I almost forgot to finish my product rule the other day. You will have some of this with A's and B's in it. Just let's keep going and see what happens. All right, the derivative of sine is cosine. So this is a cosine 3x times another 3. Chain them. I better write smaller. This one is going to be a negative because the derivative of cosine is negative sine 3x. Negative sine 3x times another 3 gives me 9. Okay, so I was here. All right, here the derivative is going to be, sorry. Was that an A?
Yeah.
You sure? Okay.
Yeah.
3a.
All right, so this is going to be negative 3a sine 3x. And this one's going to be plus 3b cosine 3x. And then I have all of this, negative 3a sine 3x plus 3b cosine 3x plus, oh wait, am I copying? plus A cosine 3x plus B sine 3x times this derivative of the first.
Yeah, this.
Yeah,
It's
you're
supposed to look
like-
like this.
Right.
So,
Oh.
like, you plug it back into the initial one and see if it equals here. But like, plug what?
And now I have all these A's.
Like that. Come on.
I'm pulling all the questions back.
That's the only thing I would do.
Well, yeah, but like,
Stop
that's a lot of
taking
work.
things. I mean, this will have problems.
It'll
below.
I know it'll work, but like, it'll work,
Skip
but.
it.
Yeah,
Skip it.
Exactly. I would never actually.
I just combined it.
Wait, who?
I just combined it. It would be like
You know,
this, and then it'd be this whole thing times e to the x.
That'd be a lot.
But it would be plus, and then you start with parentheses.
Okay, maybe I should just do it.
Yep.
Okay, so let me pause now that I finally have dragged this down here. Was that Emma's voice?
Yeah.
All right, you combined some things, Emma?
Yes.
What?
Oh, no, I was just saying, like, in that step that we just did, I, like, already combined the two parentheses, because I knew that it was like just.
Does it make a big long thing of 8? Does anything add together? Oh, you have a 9b sine 3x. So let's delete this for a minute.
You know a lot of things?
All right, so I think that's a good idea before we
A lot
go.
of things.
All right, so I'm going to factor out an e to the x. I have 9a cosine 3x. Do I have another a cosine 3x?
Just a 1.
So negative 8a cosine 3x. All right, I have a negative 9b sine 3x. And a b,
Plus 1.
so negative 8b sine 3x. All right, I have a 3a sine 3x. Ooh,
Yeah.
oh, I wish those cancel. Because this is plus product rule.
Yeah.
So I have minus 6a sine 3x. And the 3b, so you have 6b cosine 3x. All right, so now let's put this in.
Yeah, like, what's wrong?
Where is it?
This was supposed to be, I missed it.
I'd copied it. Oh well, I could just write it down.
0 is still a 1. That, and I just plugged it.
Y double prime
Minus 2y prime plus 10y equals 0.
10y or 10?
10y.
10y equals 0.
Equals 0.
All right, so I have y double prime, which is e to the x times negative 8 cosine 8a cosine 3x minus 8b sine 3x minus 6a sine 3x plus 6, oops, what is that, b? Cosine 3x?
Yes, B.
Is this a b?
Yep.
6b cosine 3x minus 2y prime, which I believe is right here. All right, so this is y, where's y prime?
All the way up. Keep going. Yeah, there.
All right, so I'm going to double all of these. I'm going to multiply all of those by 2. All right, so I'm going to have e to the x. And I'm finding 2y prime, so I'm going to double everything in the parentheses. Because I figure I'm going to factor out an e to the x anyway. So if I double everything, that's going to be negative 6a sine 3x. Negative 6a sine 3x. I'm going to be really careful. I'm doubling everything in y prime. Positive 3b cosine 3, positive 6b. What was it, cosine 3x?
Yeah.
So it's easier on a piece of paper. 2a cosine 3x.
And then 2b.
2a cosine 3x. And 2b sine 3x. Is that right?
Mm-hmm.
All right, and then plus 10y And y, I'm gonna multiply everything by 10 up here. So I have e to the x times 10a cosine 3x. E to the x, 10
A
cosine 3x
plus 10b sine 3x.
plus 10b, thanks Greg, sine 3x. All right, so I'm going to factor out an e to the x. And I have negative 8a cosine 3x. This is actually negative 6, oh, sorry. Negative 8a cosine 3x.
You should use colors to underline the different ones.
This is crazy.
Well, you're not going to have that day, so I'm just going to
Are
say.
you allowed to bring colored pencils?
I don't think so, I'll double check. I think only number 2 pencils.
I'm just hoping for a slope field for your response. And every month sucks.
All right, these are all gone, girls. This is negative 8. This is a negative 2, negative 10, and that's a positive 10. So those are all gone.
Oh my gosh, I just did it and it all canceled and it was so satisfying, guys.
Oh, it's great. Negative 8b.
Oh my goodness.
Be careful because this is negative out here. I'm looking, oh, so that's a negative 2b, which gives me a 10.
Yeah. And then the 10 at the end. And then all of the 6's canceled.
6a, and that's minus a negative, so that's gone.
That's so nice.
6b,
That was so satisfying.
and this is minus. And, oh, so I have e to the x times 0, which is 0.
Wow.
The answer is 0? That's so stupid.
They told me
That's what the whole thing was.
Hey, girls.
We're
Yeah.
like verifying that equation was
Right.
0.
Is there an easier way to do it?
Yeah, there's probably an easier way to do that.
But like we would just do it. So I
You're not gonna be able to completely escape all the A and B stuff. But there's times I work a differential equation a slightly different way. So Carla, we'll revisit it, not right this minute though. I don't think there's a much easier way to do it. There's another way to approach differential equations by going backwards. And so now my brain's thinking like, what would I do then? But anyway.
So this is how it works, this problem.
Oh, no.
I didn't want to
Girls, on a free response, there's a few that I can think of that they take you through the A and the B, and you just gotta stick with it. And it'll be something like prove like this one ended up being 0. And sometimes you'll think, I cannot tell you enough to be very literal. When you have all those A's and B's in there, it may say, prove there's a maximum at this number. And you're like, how am I gonna do with all these A's and B's in there? You still go first, what would you do with the maximum? You would take the derivative and set it equal to 0 or undefined. It will work out what they tell you to do if you're patient and you're literal, okay? Okay, now, let me look back at my list. Oh, get out your, test, if you have it with you today. And we were on number 5, Grace?
So like that example you just made up, like if like they ask.
I didn't, I got it out of the book.
Okay, no, the one you were just saying, like if they give you a lot of A's and B's and ask for a maximum, so you set it equal to 0 or undefined. In that case, would you have to set up an equation where it says equal to 0 or undefined, or can you just equal it to 0?
This one would never be undefined.
Well, not this, but like you just said one out loud that you had made up.
Yeah, you always look for, as long as it's actually part of the original, you want to know where your derivative is either 0 or undefined.
Okay, but like if you set the equation equal to 0, would they mark it wrong because it could also be undefined?
I would do both. If it's never undefined, they're not going to mark off if it can never be undefined. They would expect a good calculus student just to set it equal to 0. But if you miss the part where it could also be undefined, which we talk about a lot, just make sure it's also defined in the original. Okay, it's interesting to look at number 5 now with what you know, because now in the next test you'll look at things maybe in an even broader light. Okay, so number 5, I'm not going to do it. I'll circle the answer choice if you got the wrong one. But now you're thinking, oh my gosh, I've got all this art science stuff going on too. But do y'all see this would be a u sub, you should stop there first. You would let u be 3x squared plus 5.
Yes.
Yeah.
And go on with your life, okay? Number 6. Number 6, f of x is e to the 2 over x. Most of you got this right, but I wanted to go over this. All right, to take the derivative of an exponential function, you copy it down, you say ln of the base, and then you take the derivative of the exponent, 2x to the negative 1. The derivative of the exponent is negative 2x to the negative 2. So that gives me e to the 2 over x. ln e is 1. I have negative 2, and x to the negative 2 goes on the bottom. I wrote that super sloppy, but chain rule. All right, number 7. Most of y'all did really well on the slope fields. There were, I would say, almost every student, not every student, but almost every student that missed a slope field didn't maybe write their points down to where they could visually see them, or they didn't try enough points. Or sometimes you and I've talked, and I've talked to a few people that missed a slope field problem, and you know what you did, so I'm not going to go over these. What I would say though, is when you pick a point, choose wisely, pick something that's flatlined or that you can easily see. And a lot of us tend to pick stuff in the first quadrant. If you pick something like 3, 3, and you get a slope of 1, it probably will narrow down your answer choices, you know, and you're maybe picking between A and B. Then maybe go to the corners, and that usually will satisfy you, okay? All right, so I'm gonna skip the slope fields. I've circled it if you got it wrong. And now I'm on number 10. Number 10 is the integral of e to the x squared minus 2x e to the x squared. A, B, and C look almost exactly alike, and I had people choosing all of those, okay? For sometimes people who chose the right one for the wrong reason. Girls, Impel, okay? Some people found themselves trying to integrate e to the negative u. You can do that now based on what we talked about, but this is what I would have done first. Girls, I would not let u be x squared, most likely. First of all, I would divide it up. And I would make this 1 minus 2x over e to the x squared dx. Some of you handled this beautifully, in that you realize what dilemma you had gotten yourself into, okay? When I worked it, I rewrote it like this. I made it 1 minus 2x e to the negative x squared dx. That's because, and stay with me, I know class is almost over. In this scenario, in blue, if you let u be x squared, du is 2x dx, which is beautiful. That would give you minus the integral of 2x dx is du, and this would have given you 1 over e to the u. You have no business trying to integrate 1 over e to the u. You can integrate e to the u, but not 1 over e to the u. So then I had a few students pick another substitution. They realized that and made the back part the integral of e to the negative u du, and they used like a w is negative u, and dw is negative du, and they fixed their negative into a positive, which is, I think, the answer choice. Girls, please listen. I know it's hard at the end, okay? So listen. But this is really important. This is one that I hate to do. So everybody hold still. You don't really have to hold still, but this, okay? To avoid that whole problem, I'll let u be negative x squared right here, and du is negative 2x dx, and that gave me negative 1/2 du equals x dx, and I could keep on going with that integral, and I would have had e to the u. One more thing. Time is it? Okay. Right here. today, okay? Today, we might wanna do this and let this happen. I'm just gonna talk about the back part right now. The integral of the front part is x. I have minus the integral of e to the negative u du. When you find yourself in that position, you shouldn't be integrating e to the anything but u or x. You needed another variable, just a couple people did and got it right, okay? But Anna, you could also do this now. You could think backwards. The antiderivative of e to the negative u is you copy it down, you divide by ln of the base, divide by if you're going backwards, but then in your brain, you gotta undo that chain rule, okay? Like this. What's the antiderivative of sine 2x? It's negative cosine 2x divided by 2. You see how I'm starting to encourage you to do some of that in your head? You could have compensated for that and gotten a positive, okay? All right, homework I think will be out of the book. No quiz next class.